Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 50 in our incredible new tutorial series where you're learning how to think like an engineer using the Arduino Uno R4 Wi-Fi. What I will need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee, poured over ice, no sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this most excellent series of video lessons. And in this class, we will be using the Sunfounder Elite Explorer Kit. Now, hopefully most of you guys already have your gear, but if you don't, take a look down in the description. There is a link over to Amazon, and you can hop on over there and pick your kit up. And believe me, your life and my life are going to be a whole lot simpler if we are working on identical hardware. But enough of this shameless self-promotion. Let's jump in and talk about what I am going to teach you today. And what I'm going to teach you is I'm going to teach you how you can control the position of the stepper motor using push buttons. What I'm actually going to show you, this is the solution to the homework assignment that I gave you in lesson number 49. And what that homework assignment was to take your stepper motor with the stepper motor driver, add hopefully 4 buttons to your circuit, and the first button, every time you press it, it increments the position of the stepper motor by 10 degrees. The second button is a finer adjustment. When you press it, it adjusts the stepper motor by 1 degree. The third button goes backwards 10 degrees with each step, and then the fourth button goes backwards by 1 degree with each step. So you could sort of step the stepper motor in large jumps or small jumps to the precise position that you want. Now, this was a straightforward extension to the things that I taught in last week's lesson. And so I'm going to kind of go through fast today. If I'm going through too fast and you're not really understanding it, go back and watch last week's lesson. Okay. So that is enough of the introduction. Let's jump over here and let's see if we can kind of talk through the schematic here of how we're going to hook this circuit up. And so let me get out of your way. And first of all, we are using the components out of the Sunfounder kit. So the stepper motor that we are using is the 28BYJ-48 motor, and that is in the kit. Then as for the stepper motor driver, we are using the ULN2003, which is also in your kit. Now, what we're also using here, we always tell you you should not use your single board computer like an Arduino as a power supply. So if you're doing something like a DC motor, a stepper motor, buzzers, anything that really draw current, you want to use an external power supply. And so we are using this Sunfounder battery bank that is in the kit to power the project. Okay, the battery bank. Now, the first thing you got to do when you're working with a stepper motor is you've got to make sure that you're not trying to draw more current than the various components can supply. And so we need to kind of check that. And what we can see is if we look this stepper motor up, it can want to draw something like 250 milliamps. We are going to be driving it from this ULN2003 driver, and we see that that driver is able to source 500 milliamps. So it can source 500 milliamps and the motor needs 250 milliamps. That means those two things should be okay. Now, if we look at the spec sheet on this battery bank, this power bank, what we find is that it can provide 1.5 amps at 5 volts. And this 500 milliamps up here, it was also at 5 volts, and this 250 milliamps was also at 5 volts. So we can see that the battery bank can drive the stepper motor driver, and the stepper motor driver can drive the stepper motor, so everything is okay as far as power goes. Now, the other thing that we have told you in the past is that when you are going to be using an external power supply, you've got to make sure that all your grounds are tied together. So you've got to tie the ground of the Arduino over to the ground of the power supply, and you've got to have the various components have a common ground as well. And so you can see that we have done this here. We have taken a ground off of the Arduino and we have connected it to the ground rail of the breadboard, which is connected to the ground of the power supply. There is also a ground of the power supply up here, but those two grounds are connected together internally in the power supply. So really you don't need this wire here to connect your two ground rails together, because that's done inside of the power supply. Okay, so now what we're going to need to do is we're going to need to power up. We are going to need to power up the ULN2003, and we do this with these two connectors here. The one on the right, when you're oriented this way, is 5 volts, and the one on the left is ground. So we connect the one on the right to the 5-volt power rail, and we connect the one on the left to the ground rail. Okay, so now that has been grounded. So that all looks really, really good. And I always just like to say a few words on this power supply. It has a battery. Anytime you are using a LiPo battery in a project, you've always got to be real careful. So a couple of things. When you put your power supply away, when you put your little power board away, make sure that you have turned it off. You don't want to leave it on and just pile it into a box of components, because you could end up shorting something out. So number one, turn it off. Number two, press it back into that foam that it comes in, so that those output pins are all covered, so it doesn't just go somewhere and end up shorting everything out because those pins hit something conductive. So make sure that you cover those pins with the foam that it came in, put things back in the little sack that it came out of, and then finally set these jumpers. You have 2 sets of jumpers, one here and one here. Set them to the 0 volt position, which is the center position, and that deactivates the output pins. And so that way no voltage could end up on the output pins because you've deactivated them, and you've turned it off, and you have it in foam, and you have it in the back, and then you can be safe to put it back in your box. But you don't want to just throw batteries around such that they could short out, because these LiPo batteries can overheat. They can even catch on fire, and so you want to be very careful safety-wise when you're dealing with a LiPo battery. Okay, so we've got that hooked up. Now we're going to need to hook the motor driver. We're going to need to hook the motor driver to the Arduino. And if we look here on this side of the motor driver, you can see that it has 4 inputs. It has I in 1, in 2, in 3, and in 4. We are hooking those up to Arduino pin 2, Arduino pin 4, Arduino pin 3, and Arduino pin 5. And so this is how we are doing these connections and these connections. All right. Now the final thing that we have to do is to connect the stepper motor wires to the driver board. But for this case, it's very easy because there's a plug that has all the wires going in it, and there's only one way that will plug in. So it puts all your wires in the right position. Now, if you don't have that, Usually what you'll have is you'll have four different colored wires. A very common color scheme on stepper motors is red, blue, green, black, and oftentimes those would go to coil A, coil B, coil C, coil D. Okay, so you would look at the driver board and it should have labels coil A, B, C, D, and you would connect those to red, blue, green, black. In this case, I believe that our color scheme is orange, yellow, pink, blue, and those go to A, B, C, D. But you've really got to look at the spec sheet of your motor, of your stepper motor, and the spec sheet of your motor driver, and make sure that you're connecting the right wire from the stepper motor to the right coil connection on the stepper motor driver. Okay, so that sounds really good. Now, a couple of things is that a couple of parameters that we are going to need, the couple of parameters we're going to need on our stepper motor driver in order to play with the software correctly, the software library. One is how many revolutions in a revolution, how many individual steps does it take to go around and make one entire revolution? For this particular stepper motor, it is 2038. So we need to remember that number, 2038. Now, what we're also going to need to do is we're going to need to think about what angle does each step make? Well, what I can see is there are 360 degrees in a circle, and if I divide that by 2038, then what I can see, and I am going to check this with a calculator just very quickly to be sure. Okay, so we had 360 divided by 2038. That would mean that each click of the stepper motor will go 0.18 degrees. Each click of the stepper motor will go 0.18 degrees. Okay, so if we go 0.18 times 2038, we will get to 360. Okay, so then one click goes that far. Well, if we want to go 10 degrees, what would that be? If we wanted to go 10 degrees, what would that be? Well, if it goes 0.18 degrees per step, we would go 1 divided by 0.18, okay? And that would give us, and then we would multiply that. That would be for 1 degree. Then we would multiply that by 10, and I got to get out of your way here. And what that would be how many steps to get to 10 degrees. And so we are going to go 1 over 0.18, and that is going to be 5.6. And then we're going to multiply that by 10 degrees. And so what we see is that 57 steps, if we click the stepper motor 57 steps, that will give us 10 degrees. And similarly, if we want to go 1 degree, that would be 1 divided by 0.18, and that would be, let me just make sure, 360 divided by 360 divided by 2038 is going to be 0.18, like we said. So what this means is that it is 0.18 degrees per step, which means to go 1 degree, we would need to go 5.6 steps. So we're just going to call that 6 steps because we can't go a fraction of a step. So 6 steps on the stepper motor will take us to about 1 degree, and 57 steps on the stepper motor will take us to 10 degrees. And we're going to need those numbers when we go in and start getting this thing done. Okay, now the one other thing that we have to do here is we have also added these 4 buttons. And the buttons are very simple. The left leg of each button comes down and is connected to the ground rail. So the left leg of each button goes down and connects to the ground rail. And then what do we have going on? What do we have going on over here on the right? Let's see. Let me show you very clearly here. On the buttons, the right leg of the first button goes to pin 11, and then the right button of the right leg of the second button goes to pin 10, pin 9, and pin 8. So we go pin 10, we go pin 11, 10, 9, 8. Okay, so our buttons are all hooked up. And the way we're going to be using those buttons is we will be using pull-up resistors. And with pull-up resistors, what we have to remember is when the button is not being pressed, it will read a 1. When we hold the button down, when we press the button, as long as the button's down, it will be reading a 0. So we got to kind of keep that in mind as we are coding. Okay, I think that is what we need to really get going here. And so what we're going to do is we are going to come over here to the code view. Okay, I think you can see that okay. So let's kind of leave it like that. And the first thing that we are going to need to do, the very first thing we're going to need to do is import our stepper motor library. So that is going to be include, and what are we going to include? Stepper.h, like that. Okay, guys, and this doesn't, at least on my IDE, this did not come installed, so I had to come over here and click on this little book icon and look for Stepper, like that, and then you see I installed version 1.1.3 of the Stepper by Arduino. Now, I've already installed it, so I don't need to install it, but if you get an error like can't find the library, you need to make sure that you've installed it. Okay, now let's come in and let's set up our 4 button pins. And so those are going to be integers, and I'm going to have the R but for red button, and that's going to be equal to pin 11, I said. And then int is going to be G but, and that's going to be 10. And then int B but for blue button is going to be equal to 9. And then int Y but is equal to pin 8. Do you see when you do things logically? I like to always do red, green, blue just because it's always RGB, red, green, blue, and then yellow. And then I just lined them up, 11, 10, 9, 8. Now, why did I go backwards? Well, just because that was the order that the buttons were in, and that means that my wires came straight down without crossing over. You might say, we'll do it 8, 9, 10, 11. You could say that, but then all of your wires would have been twisted over each other. So I like to try to keep things as neat as I can as I build and program things. Now, each one of those we are going to be reading a value from. So we're going to have the R val that we're going to read. That we read, so I'm not going to set it to anything. And then I'm going to have the G val, and then I'm going to have the B val, and then I'm going to have the Y val. You see how quickly we can program when we've kind of been logical in the way that we lay things out. Now remember, to use a toggle switch and to figure out if something has been toggled or not, we need to know what the button is this time, and we need to know what the button was last time, the button value. So I'm also going to have and I think what I can do is I can just take these 4, copy them, and then I'll come here and paste them. So I'm going to have R val, and I'm going to have R val old. I'm going to have G val and G val old. I'm going to have B val and B val old. I'm going to have Y val and Y val old. So that is going along quite nicely. All right, now what I'm going to need to do is I'm going to need to set up those parameters for how many steps will make me go 1 degree and how many steps will make me go 10 degrees. And so I'm just going to say the F, the forward for 1 degree, the forward for 1 degree was what? It was going to be 6 steps, okay? And the forward for 10 degrees, int, the forward for 10 degrees, we calculated that was going to be 57 steps, okay? And then we're going to have the reverse 1 degree, and that is going to be -6 steps, and the integer reverse 10 degrees is going to be equal to, you guessed it, -57. All right, so I think that all looks good. Now we also need to tell it that 1 revolution is going to be what? It is going to be 2038 steps. And where did we get that? We got that from the spec sheet. All right, so we got that variable set up. We're moving along quite nicely here. Now let's go ahead and create our stepper object. And so we will call the stepper library, and we will create our stepper, which we will just call stepper. And then it needs to know how many clicks in a revolution. Well, that was REV. We set that up. And then what it wants is it wants pin. We need to give it the N pin. So it's going to be in this order: 2, 3, 4, 5. And why are we able to do that sequentially? We're able to do that sequentially because we kind of put N1 to 2, N2 to 4, N3 to 3, and N4 to 5. So with these kind of connected like that, then what that allows us to do over here is just input it into the library 2, 3, 4, 5. But it's a little bit strange in that, you know, you would think that this library would want N1, N2, N3, N4, but it wants the order of N1, N3, N2, N4. So it just doesn't make any sense, but that's the way they did it, and I've shown you a way that makes it work. All right, so we've got that all set up, I do believe. Let's come to our void setup, and now we need to do our pin mode. So I'm going to say pin mode, and then I'm going to do my R button, and that is going to be an input. But what else? What else, I must ask? We need to activate the pull-up resistor, because when you look at the circuit over here, we don't have external pull-up resistors, so we have to activate the internal pull-up resistors. Now, I think these other are going to be very similar to this, and so we're going to come in and 3, 4. So that's R butt, G butt, B butt, and Y butt, like that. Okay, so that's going along really, really nicely. Now we're ready to come down to our void loop, I do believe. And the first thing that I'm going to do is I'm going to set my stepper.set speed. And I'm going to put that on 10, okay, on 10 RPM. The fastest that I can go is about 19, but it doesn't always go really reliably at 19 RPM, so 15 is pretty safe. But I'm going to be really safe today, and I'm going to put it at 10 RPM. Now, what are we going to do? We got to see which button is going to be pressed, right? We are going to have to see which button is going to be pressed. So we're going to start. Let me see if I can line this up. Okay, we're going to start here, and I'm going to read the red value. The red val is going to be equal to digital read of what? The R button, like that. Now I should have whether the red button has been pressed a 0 or is unpressed a 1. Now, if R val this time is equal to 0, right? If this time it's equal to 0 and R val old last time was equal 1, that means last time it was up, this time it's down. That means we have gotten a official button push. What are we going to do in that case? So I open the if clause here. This closes the if clause, and this closes this closes the void loop. That second one closes the void loop. So what I'm going to do is I am going to stepper.step, and I'm going to go forward 10 degrees like that. Now, just to kind of debounce that switch a little bit, I'm going to put a delay of 100, a tenth of a second, and that should debounce the switch. All right, I think I can test this now. And what I need to do is, you can see I've been charging my power supply. You want to make sure that you do this with a full battery. You don't want to go into a stepper motor project with a dead battery. So make sure that you have your power bank charged up. And now what I'm going to do is I am going to download this code. Let's see how many mistakes we have. What is that before if? Forgot my friend, the semicolon. Let's try again. That's looking good. It is downloading. And boom. Now I'm going to turn this on. Okay. Now it doesn't do anything. Why does it not do anything? Because I haven't pressed a button. So let's come over here. And if I press the button, it does absolutely nothing. So what did I do wrong here? Why am I not getting any action off of that thing? Do I have... Yeah, I've got it grounded. All that looks good. So let's see what we did wrong. Stepper step is F10. If R val, let's see. I think what I forgot to do here, right here, I need to say R val old is equal to R val. So next time through, then R val old will have a value. So let's try that and see if maybe that was the mistake. I'm not sure if that would have caused it or not, but definitely I need that step in there. Okay, let's see. Yeah, you see that's moving. Do you see the little flag here? What I'm doing is I'm advancing it 10 degrees with each button push. Okay, so that is looking real good. That did exactly what we wanted it to. So just remember, to see if the button's been pressed, we've got to keep track of what is the button value this time and what was the button value last time. After we do that, then the present value becomes the old value for the next time through. Okay, so that was pretty easy. Let's just take all of this code. Let's take all of this code here. I don't need to set the speed every time, but let's take this much, and we're going to come here, and we're going to paste it. And this time, okay, this is the first one now. This is the second one, only this time I'm going to be looking at the next button, which is the G, which is the G, which is the G, which is the G, and then this is going to be G and G. And this time, I don't want to go forward 10 degrees. I want to go forward what? 1 degree, like that. So let's run this thing. This is going pretty smoothly, I think. What do you think? I think it is going to download, and I'm going to come over here. I'm going to turn this on. Watch the little flag here, and it is going to go 10, 10, 10, 10, 10. And then if I go to the green button, you see it is incrementing 1 degree at a time. Do you see that? 1 degree, 10 degrees, 1 degree, 10 degrees. Okay, that looks really nice. So I'm going to turn this off, conserve our battery power. And guys, I mean, this motor does draw a lot of current, and sometimes these stepper motors draw current even when they're sitting still. And so technically you might get an hour of use out of this, but it might be more like 15 or 30 minutes or something like that. So I don't just sit and leave my power supply on, because I don't want to just drain my battery for no reason. So let's get these two buttons that we just did. Okay, let's get those two, and now we need to do the next two buttons. Okay, so let's see, where are we? We start here. This is the red, this is the green. Now this one needs to be the blue, so I need to make it B, okay, and then this is going to be B and B, and this is going to be R10 for reverse 10, right? That's going to be reverse by 10, and then this is going to be B, and then this is going to be B, all right? And then this is going to be B. Do you see how fast you can go if you're kind of smart about labeling your variables? Okay, and now this is going to be reverse 1, like that. And then we've got to come in here, and this is going to be B, and this is going to be B. Okay, I hope I didn't miss one of those, because that can be kind of tricky to troubleshoot that if you don't change all of those things. But let's come in, let's run it. Okay, let's turn it on, and let's come here with the red button. Okay, I'm going forward 10 degrees at a time. Let's go with the blue button. And the blue button, yeah, it's working. The blue button is going backwards 10 degrees at a time, and then I'm going forward 1 degree at a time, and I'm going backwards 1 degree at a time. Is that backwards working? That backwards isn't working. So what did I do wrong on the backwards? Let's see. The reverse 1 is -6. That should work. Reverse 1 is -6. So stepper, and this is the, I didn't change the last one. What was I thinking? This last one, so I go R, G, B, and then this last one needs to be yellow. Did I forget to do yellow? Maybe I changed it to blue again. Okay, let's try that. Red, green, blue, yellow. Okay, so I go turn this on, and I'm going to go forward 10. I go backward 10, forward 10, backward 10. I go forward 1. You can see it is moving. Forward 1, forward 1, forward 1, and then backwards 1, backwards 1. Yeah, it is doing it backwards, 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 forward, 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 and then forward 10, backwards 10. Okay, I don't like that 10 business. I don't like that 10 business because that 10 business is too small. What I want to do is I want to go like 90 degrees, okay? And so that would be 1 divided by 0.18 times 90. And what is that going to be? I want to go 90 degrees at a time, all right? And so let me try that. I am going to go, I want to be very precise with this, so I'm going to go 360 divided by 2038, okay? And that's 0.1766 degrees. And then I'm going to go 1 over x that's 5.6, and then I'm going to multiply that 5.6 by 90. Is that right? Yeah, that I am getting to be right at 500. So let me see if I come up here and instead of going 57, if I go 500 and minus 500, I'm going to check that one more time. I'm going to check that point one more time. Maybe more like 510 would be a little closer. You know, when I say 0.18, I'm really kind of rounding. Okay, let's run that. I guess I should show you what I just put in. Okay, I put in 510 for forward and minus 510 for reverse. So hopefully we're going to really see something this time. So let's see if we see 90 degrees. I believe we did. Now let's go backwards. 1, 2, 3, 4. 1, 2, 3, 4. And you know, I think 1 degree is too small, so I'm going to make it 5 degrees per step, just because 1 degree is too small. So I'm going to go 360 divided by 2038 equals, I'm going to do 1 over x, and then I'm going to multiply that by 5 degrees, and that's 28. So if I make this 28, that should be 5. Now you say, wait a minute, 6 times 5 is not 28. Yeah, but remember we were rounding to integers, so this should probably be pretty much the precise number. Okay, all eyes on the little flag. So I'm going to go 90, 90, 90, 90. I'm going to go backwards, 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 backwards. Now I should go plus 5 degrees. Yeah, look at that. Beautiful plus 5 degrees. Beautiful minus 5 degrees. Boom. Okay, guys, how much fun is this? How much fun is this? And I am looking for a little wire because I want to show you something. I really shouldn't do these things on the fly, but all of a sudden I just have these brilliant ideas, and I want to show you something that would be kind of cool. Okay, now do you see that right now we are powering our project through the power board, and the power board is powering the stepper motor driver and the stepper motor, but we still have this thing out here that is powering the Arduino. So what happens if we unplug that? The Arduino goes off, and now it doesn't work because the Arduino doesn't have power. But I want to show you something. Get yourself a little wire and then come over here. Let me go. I think this would be a more suitable view. And what I want you to do is to find this VN pin. Do you see that VN pin there? Put that wire there. And now what I want you to do is come over and plug that into your power rail. And now I want you to see that the whole project is being powered off of this. And look at that. Boom, 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 boom. We are completely portable at this point. How cool is that, right? You can power your Arduino through your VN pin from this little power module. I think that is just absolutely delightful. Now, again, what you have to understand is this is just kind of for demonstration purposes. This little battery is not going to run a stepper motor for a week, right? But for demonstration purposes, you can see that we are running completely untethered here, and things are working absolutely wonderfully. Okay, guys, I hope you are enjoying taking this class as much as I am making it. As always, I want to give a shout out to my Patreon supporters. Right now, it is the support from you Patreon guys that is allowing me to continue to produce quality, fresh content every single week. So I want to thank you for that. You guys can also help me on this channel by giving the video a thumbs up and leaving a comment down below. If you haven't already subscribed to the channel, when you do, make sure you ring that bell so that you will get notifications when future lessons drop. And most importantly, share this video with other people because the world needs more people thinking like an engineer, and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.